Hello learners, and welcome to today's lesson of volume of 3D objects. Let's start off our lesson with a did you know. So, did you know that the space occupied by an object is determined by calculating the volume? Yes, the amount of cool drink in the 2-liter bottle is actually the volume of the cool drink. How much water goes into a swimming pool is calculated using the volume of the pool. The volume of objects is important and can be calculated in real life. Let's go on to the lesson objectives. So by the end of this lesson, you will be able to use appropriate formula to calculate the volume of cubes, rectangular prisms, triangular prisms, and cylinders. You'll also be able to solve problems that involve the volume of the above mentioned 3D objects. Let's look at our concept map for today's lesson. So of course, we are focusing on the volume of 3D objects. We are going to be looking at the volume of cubes, then of rectangular prisms, and then of triangular prisms, and lastly of cylinders. You should know how to calculate the area of polygons and circles, and also the conversions for the following units: milliliters to centimeters cubed and centimeters cubed to liters. Let's look at some pre-knowledge practice. So remember the area of triangles, and when we are working with the area of triangles, then we are looking at the height of our triangle. So it's important for us to know which one is the height. In a right angle triangle, we have the height that is perpendicular to the base. So in the first triangle there, the height will be our AB. And in the second triangle, which is an acute angled triangle, the height will be PR. And again, with an obtuse angled triangle, the height will be there, LM, because the height, remember, needs to be perpendicular to the base. And remember now, the formula for the area of a triangle is 1/2 multiplied by the base multiplied by the perpendicular height. Let's look at more of that pre-knowledge. So next we're going to be looking at the area of quadrilaterals. And if you remember, when we are calculating the area of quadrilaterals, we need the length and the breadth. For example, here with our rectangle, we can see there we have the length and the breadth, and a formula for our rectangle would then be the length multiplied by the breadth. And when we're looking over here at our square, so when we would calculate the area of a square, remember a square has all the sides to be equal. So all the lengths there are one amount, which means that for the area of a square, we would then say length times length, or we can also say the length squared. Then next, when we're looking at circles and we're looking at the area of a circle, now remember in a circle we have the radius, which is of course that distance from the center to the or to a point on the circle, on the circumference of a circle. So when we are calculating the area of a circle, that would then be there, the formula pi multiplied by our radius squared. So let's see if we can do some calculations based on the area of these shapes that we just spoke about. So let's start with the area of a triangle. So here we have a right angled triangle, and of course remember we need here the base and the height, which we already have here. So we have the height, which is 5 meters, and we have the base, which is 7 meters, as long as the height and the base are perpendicular to each other. Now the formula for the area of a triangle is 1/2 multiplied by the base, and we are going to multiply that by the height. So when we are substituting our values, we have 1/2. We're going to multiply that by 7 meters, and we are going to multiply that by 5 meters. And of course, now if we take 1/2 and multiply it by 7 and then multiply that by 5, that will give us an answer of 17,5 or 17 and 1/2 meters squared. And remember, because we are working with area, that means that our unit will be in square meters. So that's why our answer is 17.5 meters squared. Let's now calculate the area of a rectangle. So now we've been given a rectangle that has a length of 25 centimeters and a breadth of 10 centimeters. Now the area of a rectangle, as we have previously seen, is the length multiplied by the breadth. So when we substitute in those values, that is going to be our 25 centimeters, and we are going to multiply this by our 10 centimeters. And of course, that is going to give us an answer of 250 centimeters squared. And that is the area of this rectangle. Let's move over to the area of a square. Now, remember, a square has all the sides that are equal to each other. So now we've been given just one length, which is 13 centimeters. And because we know that all of the sides are equal, that means that all of the sides are 13 centimeters as well. So again, the area of a square is length multiplied by the length. But of course, because we know that the sides are equal, we can just say the length squared. And when we substitute our value into there, we have a 13 centimeters squared. And that will give us a final answer for the area to be 169 centimeters squared. What about the area of a circle? So, given the following circle here, we are given a circle that has a diameter of 48 centimeters. Now, if you remember, the formula for the area of a circle requires us to have the radius of the circle. And as we know, the radius is from the center to a point on the circle, which is actually half of the diameter. So, if you remember the formula is pi multiplied by our radius, and in this case, because the diameter is 48 centimeters, this means that the radius is half of that 48, which is 24 centimeters. And of course, that radius, we are going to square it. Perhaps let's just start by writing the formula first. That is pi multiplied by r squared. So that area is going to be, if we remember, pi is 3,14. We're going to multiply that by 24 centimeters, which is our radius, and we are going to square that radius. Now, when we calculate all of that, that is going to give us a final answer of 1,808,64, and that is going to be in centimeters squared. Let's now look at conversions. Remember, we said we are going to look at a pre-knowledge of how to convert milliliters to centimeters cubed. Now, if we look there on the screen, we can see that 1 milliliter is equals to 1 centimeters cubed. What does this mean? Let's look at a few examples. So, for example, if I have the 50 milliliters, now because 1 milliliter is equals to 1 centimeters cubed, how do I get to 50 milliliters? So if I have 1 milliliters and that is equals to 1 centimeters cubed, how do I get to 50 milliliters? I will just multiply both sides by 50. So this means that 50 milliliters will be equals to 50 centimeters cubed. And that is how we have converted that unit there. Let's look at the next one there. We have now 73 centimeters cubed. Now, because again, 1 centimeters cubed is equals to 1 milliliters cubed. How many milliliters will 73 centimeters cubed be? If you have 73 milliliters, then you are absolutely correct. Let's look at the next one, and that is converting from centimeters cubed to liters. So as we can see there, 1,000 centimeters cubed is equals to 1 liter. So how are we going to convert from centimeters cubed to liters? Let's look at an example. So here we have 3,267 centimeters cubed. Now if 1,000 centimeters cubed is equals to 1 liter, how many liters do you think 3,267 centimeters cubed will be? Now if you have 3,267 liters, then you are absolutely correct. We got that answer by taking our 3,267 and dividing that by 1,000. And that is how we convert from centimeters cubed to liters. Let's look at a last example there. We have 7 liters and we want to now take that to centimeters cubed. How many centimeters cubed do you think 7 liters will be? Now remember, 1,000 centimeters cubed is equals to 1 liter, or 1 liter is equals to 1,000 centimeters cubed. Now that is going to be equals to 7,000 centimeters cubed. So that is going to be equals to 7,000 centimeters cubed, and that is how much 7 liters is. Let's look at the keywords and the language that we are going to be using during this lesson. So we have area, which is the size of the surface or space. Then we have circumference, which is the distance all around the edge of the circle. That is the perimeter of a circle. Then we have the radius, which is a straight line drawn from the center of the circle to a point on the circle. Then we have bases, which is the top and the bottom of a prism or a cylinder. Now they are parallel and congruent to each other. Then we have the height, which is the shortest distance between the bases of a prism or a cylinder. Then we have the volume, which is the size of the space occupied inside a 3D object. And of course, lastly, we have the capacity, which is the amount that a container can take or can hold. And those are the keywords that we are going to be using during this lesson. Let's quickly go to an ad break, and then we'll see you just now for the rest of our lesson.